So for this section, we'll be in section 3.1, and we're going to be talking about quadratic functions and models. So first thing I wanted to do is just do a little bit of a review to make sure that we're all good for what's going to be coming our way. So recall when we talked about polynomials, we can classify a polynomial based on its degree, and then it has a name based on that degree. So if the degree is 0, we say that that's called a constant. Like if we had, just say like 2. Well, what's the variable degree? There is no variable. I mean, you could put x to the 0 here, which is really just 1. But if you just have a number, it's called a constant. If the degree is 1, that's called linear. They look like a line. If the degree is 2, this is called quadratic, which is going to be our focus today. Degree of 3 is called a cubic. And if we have a degree of 4, that's called a quartic. The other thing that's important that we learn, or just remember for right now, is transformations. We're going to be transforming a quadratic today. So in general, our equation is going to look something like this. F of x is equal to a times bx plus c squared plus d. So remember that d causes our graph to go up and down based on if it's positive or negative. C moves us left and right if it's positive or negative. And a and b are both dilations. If the absolute value of them is bigger than 1, the graph is going to get narrower. If the absolute value of a or b is less than 1, the graph gets wider. And if either of them is negative, it's going to be a reflection. Remember, a would be over the x-axis, and b would be over the y-axis. Okay, so now that we all remember that, let's get to our new section. When we're talking about quadratic equations, we're going to be graphing them. So let's talk about how to graph a quadratic function. Now we have a few different forms, a couple. One is called standard form. Standard form looks like y is equal to ax squared plus bx plus c. This is what we use to get the quadratic formula. And we also have something called vertex form. Now vertex form looks like y is equal to a times x minus h squared plus k. Now this looks like you're transforming it, right? So with vertex form, you would go to the right h units, up k units. That's going to be called our vertex. And then it's going to sprout out like whatever it's supposed to look like. We also have something called the axis of symmetry. Axis of symmetry goes right through the middle of the graph. We'll abbreviate it AOS, and we could find the axis of symmetry. Well, look, it's right down the middle, and if the vertex was h comma k, this point right here would be h comma k. It would have to be x is equal to h. So now what I'm going to do is I'll give you a few different, I think I have three different examples, and we'll go through to figure out different components of the graph. First type of example, I want us to use transformations and vertex form. So what if we had a problem like this? Y is equal to the opposite of x plus 1 squared minus 3. So we could graph it. It's going to be a quadratic to the left 1, flipped over the x-axis, or reflected over the x-axis, and then down 3. So let's see what this looks like. Here's a regular quadratic. We're going to take that and go left 1, like that. We're going to reflect it over the x-axis, like that. And then we're going to move it down 3. 1, 2, 3. All right, so let's go through our components. First thing, what would the vertex be? Well, we could just look at the equation. If vertex form, remember when we were talking about a circle, we said we always take the opposite of what's on the inside. So we're going left 1, so you could either think of it as the opposite or just going left 1, so that would be negative 1, and then down 3. The equation of the axis of symmetry would be x is equal to the h value. And then we should also talk about the intervals where the graph is increasing and where it's decreasing. Not decreasing, decreasing. This just means the graph's going up from left to right. Decreasing, of course, means it's going down from left to right. So it looks like it's going up until when the x value is negative 1. We always use open intervals. And then it starts coming down from negative 1 until forever. So that's how we would do that. What if we had another problem? What if we had a problem where we could actually use the quadratic formula to find the vertex? So we know we could complete the square and get the vertex, because when we complete the square, we would have something in vertex form. So to go from standard form to vertex form, we can complete the square. And I could show you that later on, but for right now, let's talk about the quadratic formula to find the vertex. So if you have the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, then the axis of symmetry, remember this is telling you x-intercepts, right? So if we have an x-intercept over here and over here, right down the middle, before we go adding and subtracting the square root, the middle would be negative b over 2a. So this is another way to get the axis of symmetry. If it's in vertex form, it would just be x equals h. But if you're using the quadratic formula, you could also just use negative b divided by 2a. And if we want to get the vertex, remember the vertex would actually be on the axis of symmetry. So we have an x value. We would just plug in that axis of symmetry to find the y value of the vertex. So let me show you an example. Let's say we had y is equal to 2x squared minus 4x plus 5. Okay, so first thing we could do is, let's see here. Let's get the axis of symmetry. We have a is 2, b is negative 4, and c is 5. So the axis of symmetry would be x is equal to the opposite of b over 2a. So we'd get x is equal to 4 over 4, which is just x is equal to 1. To get the vertex would be 1, and then we're going to have to plug that in for all these x's to get the corresponding y value. So the y value would equal 2 times 1 squared minus 4 times 1 plus 5. Or 1 comma, this would be 2 times 1 minus 4 plus 5 would give us a vertex of 1 comma negative 2 plus 5 is 3. That would be our vertex. So what this graph actually looks like, there's a vertex at 1, 3. The axis of symmetry is at 1. And because this leading coefficient is positive, the graph opens up. And if you wanted to get a better idea, we could always find the y-intercept by plugging 0 in for x. We'd get y is equal to 2 times 0 squared minus 4 times 0 plus 5 would just give us y is equal to 5. So I'll make this a little bit more narrow. And that's what it would look like. So let's finish this up by talking about what interval it's increasing on, what interval it's decreasing on, and then we'll do one more example. So this graph is increasing, starting at 1. It looks like it goes up for forever. It decreases from negative infinity up until the x value of 1. All right, and then for our last example, what I want to do is show you how to get vertex form from quadratic form. So let's do this, or from standard form to vertex form. We're going to be completing the square. Remember, standard form looked like this, and vertex form looked like this. Okay, so our example is going to be this. F of x is equal to 2x squared plus 4x plus 5. All right, so when we were talking about quadratics, quadratic equations, we said that completing the square is a technique we could use to force something to factor. So let's go through our steps. First step was we isolate the x's. So we get 2x squared plus 4x, and we'll just get 5 out of the way. Second step is we factor out the leading coefficient from the x's. And in order to do that, what we're going to have to do is take out the 2. So we would get f of x is equal to 2 times x squared plus 2x, and then we still have the plus 5 over here. For our third step, we're going to take half of the middle number, and then we're going to square it. So that means we're going to take 2 divided by 2 and then square it. So we'll say f of x is equal to 2 times x squared plus 2x plus 1 and then plus 5. And then for our last step, we really just added 2, right? So 1 times 2 is what we added by putting the 1 there. So for our last step, we have to balance things out. So we multiply the new number by the front and subtract to balance things out. So this would be f of x is equal to 2 times x squared plus 2x plus 1. 2 times 1 is 2, so we're going to subtract 2 plus 5, and we get f of x is equal to 2. It's always going to factor to be half of the middle, We talked about that before, x plus 1 squared plus 3. And from now we see that it's in vertex form, so we took something in standard form and converted it to vertex form. Let's go ahead and graph this. Now looking at this, it looks like the vertex, we're going left 1 up 3. Which means the axis of symmetry would be x equals -1. We could also find the y-intercept by making x equal to 0 in either the original or the new problem. So it doesn't matter which one you use. Usually the originals are a little easier. So 2x squared plus 4x plus 5 is the original. And if we put 0 in for all the x's, you just get y is 5, which makes sense. Get a parabola looks something like that. Now the interval where it's increasing looks like it would start at -1 and then go up until infinity. And it's decreasing from -infinity to -1. What I wanted to do to finish is just find the x-intercepts also. You could see they have to be imaginary because it doesn't cross the x-axis. So let's do this with the standard form. Remember, the way we get the x-intercept is we make y 0. And let's do this with vertex form, just to make sure we're getting the same thing. So we have an a, we have our b, we have our c. So using quadratic formula, we're taking the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, and a was 2. So we get x is equal to -4 plus or minus the square root of 16. Let's see what this is here. 16 minus 8 and 5 is 40 is -24 over 4. We're going to take out an I from that radical, and then we have to break down 24, which is 6 and 4. 6 is 3 and 2, 4 is 2 and 2. So we have a group right here with a 3 and a 2 left over. So we'll write 2I root 6 over 4. Remember, our group goes outside, and what's left over goes in. And then we can still simplify this. Let's take out a factor of 2 from the whole top. And we'll take out a 2 from the bottom. We'll get x is equal to -2 plus or minus I root 6 over 2. That's our x-intercept. We should get the same thing using vertex form. So let's bring the 3 over. Divide by 2. Take the square root. Remember, this turns into absolute value because you're taking the square root of something squared, or an even root of an even term, and you get x plus 1 to the first. So even, odd, we need absolute value. We are going to have to rationalize this, multiply by root 2 over root 2, and we get square root of -6 over square root of 4. We can get rid of absolute value by writing plus or minus, and then bring the 1 over. Now this doesn't look like what we have on the left, because if we get a common denominator, multiply by 2 over 2, you get x is -2 plus or minus I root 6 all over 2. So it is exactly the same thing.